Period. Okay, here we go. Done stalling. All right, let's get through this. Let's go back to rolling a die. All right, somebody just chime in right now. What's the total number of outcomes when you roll a die?
6.
6 outcomes, all right? We know that. We're very used to rolling a die in this class. We've had a ton of questions. Next one says, hey, can you list out the sample space? Meaning, list out all the outcomes for me. So you guys know when you roll a die, you could roll a 1, a 2, a 3, a 4, a 5, or a 6. We know that very well. So those are my choices for rolling a single die. All right, let's go through some review questions, and then I'll add in our little wrinkle here at the end. Even number. Probability you roll an even number. This is all basics for us. So let me ask you guys. Probability I roll an even number here. 12. Here we go. Dan, I roll an even number. What are my chances?
1 out of 3.
What was that?
1 out of 3.
1 out of 3. You sure about that? How many even numbers are there?
Aren't there just 3
Out of how many choices?
out of 6?
6, right?
So yeah, it would just be 1/2.
So out of 1/2. Everyone's all right? 3 out of 6, 1/2. All right, let's keep trucking. A number greater than 4 for me. What's the chances you get a number greater than 4? Here we go. 9. Hunter, greater than 4. What do you got for me?
2, 6, or 1/3.
Yep, 2, 6. Thanks for reducing it. 1/3. You could get a 5 or a 6 there. 2 choices out of the 6 total. How about a 7 now, kids? Probability I roll a 7. Boom, here we go. Nick, good morning. I roll a 7, Nick.
0.
0, that's an impossible event. So any impossible events have a probability of 0. All right, let me change it up on you now. What's the probability I roll an odd number or something greater than 4? An odd number or something greater than 4? All right, let me take my time on this one now. Here we go, Hunter, back to you. Let's take our time on this one. Hunter, what are your choices for odd numbers?
You got 1, 3, and 5.
Okay, everyone watch what I'm about to do on my sample space. 1, 3, and 5. Everyone's good. All right, Hunter, what about number greater than 4? What are my choices?
5 and 6.
All right, 5, but I already circled that, so I don't need to circle it again. I don't want to count it twice, guys. I don't want to count the number 5 twice. So I just leave it circled and 6, he said. So, Hunter, how many choices do I have?
4.
Yep, 4 out of 6 choices, which reduces down to 2/3. The point I wanted to get there, guys, is do you guys see that I did not count the number 5 twice? I don't want to count the number twice. I only count it once. So does everyone see why there's 4 choices versus 5 total choices? I don't count the number 5 twice, only once. We good? Okay, a couple more with the die, and then we'll go to cards. Probability you get a 3 or a 5 here. 3 or a 5. Here we go. Bassett, a 3 or a 5. How many total choices do you have for the top?
2.
2 out of
6.
6. You got it. So that's going to be 1/3 for us. How about a number less than 3 or a 6? A number less than 3 or a 6. Okay, 5. Here we go. Ella, good morning. So how many numbers are less than 3, Ella? 2, and then there's only how many 6s?
1.
1, so how many choices do you have here?
It would be 3 out of 6 or 1/2.
Good job. 1/2, 3 out of 6. Everyone's okay on the die. Now, I know maybe some of you in the back of your mind are saying, wait a second, you just made a big spectacle of yourself at the beginning. If a problem had the word or, we were going to add. And we never added here. I know. That's because this was easy. Because I could just list out numbers 1 through 6 and do it looking at that. All right, this one was easy. I didn't have to add anything because I could simply just look at my choices and figure out how many possibilities there were. Sometimes, though, you don't want to write out all the different possibilities, like a deck of cards. All right, there is no way you want to list out all the cards in a deck. I'm not doing it, and you sure as aren't doing it either. So let's review first what consists of a deck. Anybody remember how many outcomes in a deck of cards I have? Go ahead, chime in if you do. How many outcomes in a deck of cards?
52.
5-2. There we go. 52 cards. I'm not listing all 52 out. That's for darn sure. 6 I can handle. Six numbers on a die, but 52, no, we're not listing those out, guys. All right, remind me again. Anybody remember what the suits were called? 4 of them.
Hearts.
Okay, there's 13 hearts in a deck of cards. Anybody remember the other suits? You got them.
Spades.
Spades.
Hey.
Trying to get you guys more confident just to speak up and do your thing here. All right, I'll just take it over. Clubs, 13 clubs, and then 13 diamonds. Okay. Face cards. We did not talk about that the other day when I reviewed the deck of cards. Face cards. Those are the cards with actual faces on them. You have 4 kings in a deck of cards. 4 kings. That king is referred to as a face card. And you have a king for every suit. So there's a heart, spade, club, and diamonds for kings. Another face card is called a queen. And you have 4 queens in a deck of cards. 1 for every suit. And then there's one other type of face card, and that's a jack. 1 for every suit. Okay, so that's what's considered a face card in a deck of cards. Kings, queens, and jacks. And then you guys go ahead. What were the 2 colors of the cards? What are my 2 colors?
Black and red.
Yep, black and red. And again, reminder, half the deck, 26 is black, and the other half, 26 is red. All right, so a review of cards, because we're going to be working with cards a lot today and the rest of the unit. Any questions on the makeup of the deck? Okay, so let's do this. 1 card I choose. What's the probability you choose a queen now? Probability you choose a queen. Just a queen. Woo-hoo, 11. Liz, good afternoon. Good morning. Liz, how many queens did we just say were in a deck of cards?
4.
Out of?
52.
There you go. 4 out of 52. So that's going to be 1 out of 13, everybody. A heart now. What's the probability you guys pick a heart out? Oh, I don't know why that showed up. How about a heart in a deck of cards? 5. Ella, here you go. How many hearts in the deck of cards, Ella?
13 out of 52.
Good job. 13 out of 52, 1/4. Good job. All right. Now here's where I get to the new stuff. What's the probability in part C you get a queen or a heart? A queen or a heart. Now, I am not going to list out all 52 possibilities and circle all the queens and all the hearts and count them up like I did for the die. Way too long. So now I'm going to resort to, hey, I see the word or now, a queen or a heart. So what I want to do is add those 2 probabilities up now. Okay, this is where I want to start adding when writing down all the outcomes is a little bit too much work. All right, so let's add both together here. 1, 4, here we go. Eliana, what was the probability of getting a queen again?
13.
Okay. Yep, you can use either one, guys, because you guys have calculators. I always use the 52 one, but you have calculators, so you can use either one. 4 out of 52, and then Eliana, what was the heart?
13 out of 52.
Okay, everyone stay with me now. So is everyone okay where these fractions came from? 4 out of 52 for a queen plus 13 out of 52 for a heart. Here's where we got to really buckle down and be studs now. Now you have to think, is there anything they have in common? Is there a card out there that could have a queen and a heart at the same time? Think about it. Anybody, yes or no? Is there a card out there that's got a queen and a heart at the same time?
Yeah.
Yeah, it's the Queen of Hearts, right? I'm sorry, I'm going to do such a poor job here, but I got to get the point across here. Right? You got the Queen of Hearts. But remember, didn't you include it as a queen? And you included it into the hearts. We can't count it twice. We can't count it twice. So if there is a card in common, like the Queen of Hearts here, I need to subtract out 1. Because I counted it twice and I can only count it once. All right, everyone see why I need to subtract 1 from it. Because I counted it as a queen and I counted it as a heart. But I could only count it once. So that's why I need to subtract out the 1 they have in common. All right. You have 2 choices. You can go to the calculator, or they all have the same denominator here for me, which is 52. And now 4 plus 13 minus 1. I add the numerators up. And that's 16 out of 52. Reduced answer. What I have there for the reduced answer. 4 out of 13. So when I'm adding probabilities together, I have to remember to maybe, sometimes it's not needed, maybe I need to subtract out if they have something in common. All right, good? And then part D, what's the probability of the Queen of Hearts? There's no or here, just the Queen of Hearts in the deck of cards. Queen of Hearts, what's the chances I pick that one out? 9. Yeah, Hunter, Queen of Hearts, how many are in the deck, Hunter?
It's 1 of 52.
Only 1 Queen of Hearts out of the 52. Yep. That's it. So different problems with the Queen and a Heart. Any questions here, specifically with the or, because I got a couple more to do with you. Okay. Last 2 here. Find the probability of picking a 2, or there's that key word, circle it, because that's what I want you to do Monday on your assignment. You see the word or, a diamond from a deck of cards now. 2 or a diamond from the deck. All right, well, the or tells me you guys better be adding up here. Adding up both probabilities and then thinking at the end, but we'll get to it. Okay, everyone think, picking a 2. Somebody's going to give me the probability, picking a 2 out of the deck. I'm just so fired up here. I lost everything. Dan, here we go. How many 2s are in the deck of cards? 1 for every suit. There's a
Wait,
2.
how many?
There's 2 of hearts, 2 of diamonds, 2 of spades, and 2 of clubs. 1 2 for every suit there is. So how many total?
6.
What are the 6? You got 2. You got 2.
You got
2 of diamonds.
Yeah.
You got 2 of spades. You got the 2 of clubs and the 2 of hearts.
Oh, I forgot about the diamonds. That's fine.
But there's going to be less than 6, though. I'm saying the 2 of diamonds is 1 card. The 2 of spades is a card. 2 of clubs is a card, and 2 of hearts is a card. There'll just be 4. Remember, any number, guys, there's 1 for every suit. Okay? 4 out of 52. And then how about the diamonds now? What's the chances you get a diamond out? Here we go. Dan again. Let's go. What diamonds? How many diamonds? We just went over that one in the last page. Diamonds.
So it would just be 1 out of 4.
Yep. I'm going to keep, you can write 1 out of 4. I'm going to keep the 13 out of 52 here. Did we count any cards twice? Picking a 2 and a diamond. Did we count any cards twice? I think we did, didn't we?
Yeah,
What did we count twice, Caroline?
the 2 of diamonds.
Yeah, the card that has the 2 of diamonds. We counted it as a 2, and then we counted it again as a diamond. We can't count it twice, so subtract out once again 1 out of 52. Okay, cannot count them twice. And usually with cards, it'll be, yes, 1 out of 52. All right, and then we end up with 52 in the denominator, 4 plus 13 minus 1, 16. If you guys are using your calculator, great. You keep using it. It'll give you the reduced version, I believe, which is, we just did this, 4 out of 13. And then last one here. Some kids taking French and statistics. 8 take both, because I guess they're studs. 8 take both. If I pick a student at random, what's the probability is taking French? There's that word again. French or statistics. So I see, okay, or let's add up the probabilities now. Let's add up the probabilities. So how many are taking French? What's the chances for French? 15. Kian, what's the chances for French?
42 out of 100.
Good. 42 out of 100. If you're wondering where Kian got the 100 from, it's at the beginning of the problem of 100 students. Good, Kian. Nice job. How about statistics? 7. Here we go. Will, how many are taking statistics here?
26.
26 out of 100. Now we got to be careful when we're doing an or one, right? Is there anybody we're counting twice? Anybody we're counting twice? Yeah, how many? We're not just one here, right? How many are taking both? 8. Everyone see that? 8 take French and statistics. So we need to subtract out 8 because we've counted them twice. Only in these or probabilities I got to worry about maybe subtracting some out. And then you guys are good from here, either using your calculator, keep the 100 in your denominator. 42 plus 26 minus 8 gives you 60. And then if you want, you could reduce that down to 3 out of 5. Okay, good work, guys. Good work. Any questions you want to ask on the or? Because this I'm at the halfway point now of today. Probability of an or event. Add them, and then, if possible, subtract out what you counted twice. Okay, take a quick break. Get a breath or two in you. Get a drink. Something, obviously, nothing stronger than ginger ale around you guys. Oh boy, that'd be some crazy probability. Big weekend plans, anybody?
Yeah.
Oh, yeah?
Yeah, huge.
I figured everyone had big plans in the middle of a global pandemic, right?
No, I'm just going to Trader Joe's.
I do have one important thing. This weekend through work, I am getting the vaccine. I signed up to take it.
Wow.
So this Sunday I'll be taking it.
So you will be halfway to immortality, Mason, huh?
Yeah, I'm making my way.
All right. Good, good. Anybody else before we move on? Okay, good talk. Just trying to get to know each other a little better, kids. Sorry, it's not all about the probability with me. Trying to get to know my students a little better. All right, here we go. Second half of today. So we went over this or probability. And so far in this unit, we've rolled a die once. We've picked one card. We flipped one coin. We spun a spinner once. Now we're going to start doing something more than once. All right, we're going to do multiple events. All right, multiple events. And when we do multiple events on one problem, these events can be considered either dependent or independent. And instead of explaining the difference between the dependent and the independent, I'd rather just go right to a problem right now. So you guys can see number one, we did two things. We rolled a die, then spinned a spinner. And I want to know, are these dependent or independent, these two? So here's what I mean by this. You roll the die. Boom, you roll the die. Does the outcome on the die have any effect on the outcome on the spinner? Let me say that again so you guys can think about it. When I roll the die, does that have any effect on my outcome on the spinner? Absolutely not. No, right? So if they don't have any effect on each other, we say that they are independent of each other. Independent. If one event does not have any effect on the next one, we say they are independent. All right, let's go to number 2. You're going to pick 2 flashcards, but you're not going to replace the first one. So again, you see this? Without replacing the first one. So I pick the first flashcard. Does the outcome on the second one, is that affected by me not putting it back in?
Yeah.
Why? Why is it affected? Because you started out with 30 flashcards, but now since I keep the first one, how many choices do you have now?
29.
So everyone see that. Now you have 29 instead, and that affects your outcome. So when one event affects the other, we say now they are dependent. They depend on each other. So me keeping that first flashcard will affect my second pick, because now I don't have 30, I have 29 to choose from. All right, now that we have independent and dependent, let's see a random one now. You got coins in your pocket. You replace the coin and pick another one. You replace the first coin and pick another one. So what do you think? Will that replacing it have an effect on the second pick of the coin? Will it affect the outcome on the second coin if you replace the first one?
No.
No, it will not. So if it doesn't affect it, if the first event does not affect the second, we say the 2 are independent. Okay? So I just wanted to get those words out to you, independent and dependent. Independent means the first event has no effect on the second one. If it does have an effect, like it did in number 2, we say they're dependent on each other. How do you find these probabilities now of independent and dependent? How do you find them? Now, instead of adding, we are going to multiply. And I'll make this as easy as possible, just like I did with or equals add. 2 events equal multiply. 2 events means I'm going to multiply. It'll be plain obvious in the directions that 2 events are happening. You multiply the probabilities now with 2 events. There's no key word to look for. We just got to know we're doing something twice. All right, let's dive right into it. I want to talk to you guys again. I miss talking to you here. Look at number 2. Hey, 2! Guys, 2 dice are rolled now. So that tells me I'm about to multiply a couple probabilities together. 2 dice. Not 1 anymore, 2. Oh, you want me to roll more than 1? We're going to multiply the probabilities. So find the probability of rolling 2 6s. 2 6s. Caroline, here you go. Ready? 2 6s. So Caroline, die number 1. What's the probability you roll a 6?
1 out of 6.
1 out of 6. Die number 2. What's the probability you roll a 1 out of 6?
1 out of 6.
Right? The first one doesn't have an effect on that one. So I have 1 6 times 1 6. If you guys need your calculator, fine. But remember how to multiply fractions. Numerator times numerator. So 1. Denominator times denominator. But look, if you got to use the calculator, use that sucker, please. Use it. Use it. All right. Good job, Caroline. All right, B. A number divisible by 2 and an odd number. All right, so I'm still rolling the 2 die. Still rolling the 2 die here. 9. Here we go, Hunter. Back to you. Ready? Die number 1, Hunter. A number divisible by 2. What do you got?
4.
4?
And 6.
Or the number divisible by 2. There's how many choices? Remember, Hunter, you're not taking this all at once here because there's not an or here. All right, you're taking just a die number 1 is a number divisible by 2. How many choices?
3.
3 out of 6. And then the other die is an odd number, which would be what?
3 out of 6.
3 out of 6 again. Yep. All right, everybody all right. 3 out of 6 on die number 1 for a number divisible by 2. And on die number 2, an odd number, also 3 out of 6. So now top times top, you guys got 9 out of 36. 1 out of 4 shot. Everyone good? Questions? All right, let's get away from the die now. Let's go to bags of marbles. 6, you guys can read how many there are. The next part is key. Please, please, I'm begging you in this unit, read carefully. A marble is selected, replaced, so I put it back in. And a second one is selected. Oh, wait. A second one is selected. 2 marbles I'm going to pick. Definitely got to multiply. 2 marbles. You pick a black, then a yellow. Black, then yellow. All right, so let's go black first. Nick, here we go, big dog. Black marble out first. What do you got for me? How many black marbles are there?
6.
6 out of how many marbles?
21.
21. So that's black marble, everyone. 6 out of 21. If you need to make a note, that's my choices of a black. You put it back in the bag. Put it back in the bag. Now let's go yellow. What are your chances of a yellow here? You got it. 3. Here we go. Anna?
4 out of 21.
4. Now, Anna, quick explanation to your classmates. Why is it still 21?
Because you put the marble back.
Correct. I put it back in the bag. That may not be the case coming up. Good job, Anna. So everyone, all right, there's the black probability and the yellow. Multiply them. 24 out of probably a pretty darn big number. 441. If you guys are using your calculator, it'll probably reduce it down to 8 over 147. Draw 2, you multiply. All right, do something twice, you multiply. All right, let's keep going. I'm only going to do 4 and 5. I'm getting rid of 6, so we're done after 4 and 5. All right, let's look at Cindy. We are going to go back to the deck of cards. Read through it. Look what she does, though. After she picks the first card, she's not going to put it back. Without replacement, she's not going to put it back. So give me the probability she draws a 2 and then a 5. So 2 cards, right? She's drawing 2 cards, so we know we're going to multiply. And if you got, I just like doing this down so I can show you guys where everything's coming from. So here, somebody's going to give me the probability. Draw a 2 now, everyone. Draw a 2. Probability you draw a 2. 8 spot. Here we go. Colin, good morning. Good to hear from you today. You draw a 2, Colin. What do you got?
4 out of 52.
Good job. All right, you ready here, Colin? This is where the great ones shine. You're not going to put that card back. So now tell me, what would be the probability of getting a 5 now?
5 out of 51.
Okay, I got the out of 51. How many 5s are in a deck, though?
Oh, 4.
4. And explain to your classmates why you said out of 51 and not out of 52.
Because you didn't put the 4 back.
Good, everyone hear that? All right, I didn't put the 2 back that I picked first. So everyone see how it went from 52 to 51 when I do not replace. Solid work, boss. So that gives me 16 out of another large number. 2652, 2,652. So pretty slim chances, right? You get a 2, keep it, and then get a 5. Slim chances. And then reduce, it was 4 out of 663. Whew. Pretty slim. All right. I really want to hammer this home now. This concept of replacing, not replacing. So let's finish up with number 5, parts A through D. You guys read how many tennis balls we have and how many colors we have of them. Okay, you're going to draw 2 tennis balls, so that tells you, okay, I'm going to multiply them. Yellow, then pink, with replacing. You're going to go yellow first, then pink, with replacing the first one. All right, who's up? Who's up? Come on. Will, here we go, Will. You got this, boss. Yellow, Will. How many yellows are in there?
3 yellow.
3. Did you count up how many balls yet, Will?
You have 14. 16.
16. There you go. Now remember, you replaced the first one, Will. So how many pinks are in there?
There are 7.
Out of how many?
16.
Good job. Still the same 16. There we go, Will. So there's part A. And just to do the math real quick for you guys, that's 21 out of 256. And that does not reduce. Yeah. All right, here we go. Part B. Same question I just asked Will, but now without replacing. So you're not going to have the same fractions there. You're going to have a little something different. Oh, Will, let's go. You got the yellow-pink train. Ready? Yellow.
3 over 6.
That-
15.
Yep, that's still not going to change. All right, Will, I don't put it back in now.
7 over 15.
Yeah, there we go. Everyone all right on why 15, Will?
Because you didn't replace the, let's see, yellow.
Yep. So now instead of 16 tennis balls, you get 15. Good, Will. Good. Can't get by you. 21 out of 240. And you guys reduce it on your calculator, 7 out of 80. All right. Let's bring this train home. Let's go pink, pink. Pink, pink with replacing. Pink, pink. Ooh. Colin, back to you. Here we go. Pink, pink with replacing, Colin. Come on. Be big, Colin.
7 out of 16.
Yep.
And then it goes 6 out of 15.
You didn't replace, though. I'm sorry, with replacing here. So you put that
right.
first one back. So it's still going to be what?
7 out of 16.
There you go. Good. 7 out of 16. 7 out of 16 when I put it back in. 49 out of 256. I don't know. Did that reduce? Nope. Does not reduce. All right. Let's go on the weekend strong. Let's go into this weekend strong, kids. Pink, pink without replacing. Colin, let's go. Look at you, Will and Colin here. Pink, pink without replacing. You got this now because you almost told me before.
7 out of 16 for the first one.
Yep. Now be careful. Everyone focus in here. Be careful on this second one. What do you got when you don't put that first pink back in?
6 out of 15.
There you go. 6 pink now. 15 tennis balls because I kept the first one. Good. And that's going to end up being 42 out of 240. Reduced version, 7 out of 40. So ors, I'm going to add them. 2 or more, I'm going to multiply them. And just watch out for that with and without replacing. Guys, I thought you did a heck of a job today. Thanks for staying with me for so long. I do appreciate it. We're going to practice all this on Monday. Okay? Thank you for sticking with me. Guys, relax this weekend, but be smart about what you do, right? You guys got to reach out to me. Feel free. All right. Have a good weekend, guys.
Have a good one, Charlie.
See ya, Isaiah.